Hello, we're going to take a look at using Microsoft Excel as a data cleaning system. Excel is perhaps the most popular spreadsheet software that there is in the US. Most major companies and nonprofit groups have used Excel in some form or fashion for every task from handling tables to building flyers to handling their budget. What we're going to look at using it for is, as historians, how we can manipulate large batch data, such as that's found in the US Census, and how we can turn that into a usable format that people can read and that computers are capable of reading for tasks such as visualization and other projects that we might face. What we have before us right now is an example of what you do not want to see. This is the nightmare scenario. You've gone through several systems to manipulate and build a data set. You load it into Excel thinking, I can finally get to the point I can make my pretty charts and tables that people can understand. And when you import, it's garble. Once you have data that gets to this point where you can only see small components of it, you can't really break it apart and get a useful or set of data that you can feel confident in using. You have to consider whether or not it may be valuable to just start over and rebuild the spreadsheet by hand, which is an option. It's what Excel is built to do. It does it very, very well. It can be time-consuming depending on how much data you actually have to enter. Some systems, such as Tabula, are designed to help you move from PDFs or other pre-made text documents or scans and move them into spreadsheet software, but you can have mixed results. This data that's actually here is the product of one of those attempts. We're going to move from this data. It would take quite a bit for us to turn it into something functional for us, to a cleaner set of data out of the US Census. What we can see here is we have nice clean charts that are all consistent in the way that they're formatted. Everything looks reasonable for what we have to do. One thing to always note when you're working with anything historical, especially census data, is to look at exclusory notes that are up at the top, as well as the notes on how the data was obtained and how it was digitized down at the bottom. It's important to note that, and this is a historian's job, to understand that census data isn't always as accurate as it's played up to be, in part because of the way that census data has been collected historically. If you're going to use data from those forms, make sure that you know what you're actually getting. It can end up sinking good research based on poor understanding of the way data was collected and introducing your own biases into what you're trying to produce. What we have here looks very, very nice. It looks like it's ready to go, and we're ready to see what we can produce with it. So, just for an example, let's pull up all of our data, combine it all We will combine it all together, and we will try to run a visualization using Microsoft's own chart building functionality. We can click Recommended Charts. Doesn't seem that it has any recommendations, so let's pick something like a column chart, or perhaps a line. Oh, well, we're running into a problem now, aren't we? We can't see anything based on this data. It's all clunky, and it doesn't look like it's telling us anything useful at all. For example, scatter plot. There's nothing there. They're all just dots. The reality is that the data we have is not cleaned. It looks like it is. It's fairly readable by a human. Fortunately, it's not in a system that a computer can read. in part because in our attempts to make things visually stimulating for humans, we tend to make them more complicated than they need to be for a computer system. So let's go back and take a look at what we need to do to clean this data up and make it possible for the computer system to be able to generate a visualization that is useful. When we look at our table, we notice a few things fairly quickly. We see these column headers that stretch across more than one column. Microsoft Excel does not have the capacity to read these as headers. So we can remove our merge and center on them. Then we can transfer those headers. Always make sure that you take advantage of the undo button. It's very, very handy. I'm simply copying and pasting these into making it look the way that it should. We've got another merged component here. All right, now when we look at our data, we have a little bit better idea about what actual information is presented in our tables. We have not one set of data, as we saw before, but three completely different sets of data. We have totals for all races, white and non-white individuals. We also have totals for males and females of each of those categories. Not only that, but we also have a total row right here, which can drive you nuts because you instantly add 50% more people than you actually have in your sample size. So let's start to clean those up. And this is when what you're intending to use the data to show comes into play. And your skills as a historian are important. For simplicity's sake, let's eliminate these total rows. We don't really need them. Let's also say that we're going to emphasize working with all individuals rather than either white or non-white. It's important before you start manipulating data, always keep a backup of the file in case something goes wrong. It's much easier to start over with an interim step than it is for you to start over from scratch in editing your data. In our case, since this is a demonstration, I don't really need to do that. I already have backups of all these files. So we will delete out these columns, and now we finally have a set of data that is useful for a computer. Almost. We've finally gotten it down to one, but yet again, we notice there's a total column. We don't want to duplicate our work or double our sample size for any of our information. So we'll go on ahead and delete out that total column. And now we're finally to the point that a computer system is capable of reading what we have. We've limited the number of variables that are a part of those visualizations to simply age, gender, and the total. So now that we've done all of these steps, we will highlight the data that we have available and we want to use, and we'll try to run it through that recommended charts again. And we have some useful suggestions. So let's go with the clustered column. It tends to be the easiest to read for this particular type of data. We'll blow it up to make it a little more eye-friendly for everybody at home. All right. Let's add some headers and access titles so that we can actually tell what is on those titles. Our left-hand side appears to match the numbers for total population, meeting those criteria. Our bottom axis appears to be the age of those individuals represented. And we can tell that we have two sets of colors, one which is blue for male, one which is orange for female. So we'll put a title on here so that we know what we have. We have age of population by both count and gender. It's important to note, once we've done that, we need to take a look at our chart and see if it seems reasonable and would match up to the way that we would anticipate an age distribution varying. This is also where your historical skills and your historical knowledge come into play. It seems fairly straightforward. There would be lots and lots of very young people because we had large family sizes in 1909. It would seem feasible that we have very few people who are older in 1909, given the fact that there wasn't quite as many medical advancements that were able to help people survive. The one thing that does stick out is we get all the way to the right-hand side, which should be our oldest population, and then we have a gigantic spike. What could cause this? Well, when we take a little bit of a closer look at it, we see that this is actually an aggregate field rather than a single point field. Rather than expressing that there are hundreds of thousands of 75-year-olds as opposed to 74-year-olds of whom there is a small number, we're seeing everyone over the age of 75. In our case, that doesn't really give us much usable data to help understand and comprehend what's going on. There's two ways to eliminate that data. We could either delete the individual bar, but wait, we've lost all of our female components. We will back up, and we can delete just that field, and ta-da, our chart looks much, much better and makes a lot more sense. We can make other manipulations within this system to refine the way that our chart would appear, but it seems pretty good right now as a way of explaining the general age trend in both males and females in 1909 when the census was taken. One thing to keep in mind, though, especially with using census data in this fashion, this is aggregate data that you're using anyway. If you want to get to demographic trends within a single area, you're going to need more specialized aggregate data. You can't draw those conclusions from just the general U.S. Census. Other than that, you don't really run into too many problems. Excel is a very, very good system for making these sorts of alterations and doing these basic visualizations as a way of understanding the data that you have available to you. Excel is not very good about making global changes or doing standardization work. If you have multiple derivations of the same name, it's very clunky. You have to edit each cell individually. If you have to look for patterns within your data that are non-numerical, Excel does not work very well for that task. You're better off using OpenRefine or another system in that fashion that's capable of pulling up collated lists of information and looking for patterns itself. If you have to build spreadsheets from raw data sources that you either cannot scan or you have to assemble from various collections of data, Excel works very, very well for those tasks. For visualizations, Excel works okay. It works well at making charts and graphs and things that are manipulatable and able to be moved into PowerPoint, Word, and other Microsoft products. Most systems nowadays are being adapted to accommodate Excel spreadsheets because of how popular the system is. That being said, it still is private software, so not everything will be compatible with it. You'll just have to try to work with that. If you are unsure of how to use the various components of Excel, there are lots and lots of tutorials out there, both on YouTube, on systems like lynda.com, or just through open internet searches. You can get into more advanced functionality and algorithmic work in Excel using things like pivot charts and formulas. For what we're interested in doing right now, that's a little advanced. If you're interested in those things, I would again suggest that you go look online for those tutorials, or if you have access to IT services, to inquire with those individuals about training opportunities. Other than that, Excel works very, very well for what you're doing if you keep in mind both your historical practice and tendencies in the data that you're actually going to use, as well as understanding that it's built for building spreadsheets and doing basic analytical work. It's not designed to do all of the jumps and loops that many heavy analytic systems are capable of. With those two things in mind, you'll find it very, very handy as yet another item that you can put in your historian's toolbox for working with data.